Very good morning, my dear students, and welcome to Digital World of Patania Public School. But today we start typecasting. Typecasting. We already know about the expression with mixed type also. Expression like a plus b minus c, a plus b divided by d. Python internally changes the data type. Python internally changes the data type of some operand so that all operand have same data type. For example, you write down int 3.5, but integer is the whole number. Integer is only 3 number, but you write down 3.5, so it display only 3. But when you write down float 3.5, then its answer is 3.5. For example, you write down float 7 by 2, so it gives the answer 3.5. But when you write down int 7 by 2, so it gives the only answer integer. So internally Python changes the data type of some operand that all operand have same data type. This type of conversion is automatic, implicit, and hence known as implicit type conversion. We know later what is the explicit type. Python however also support the explicit type conversion, and if we want to convert the integer to float and float to integer and float to integer float and your complex number in your string, then we change it with the explicit type conversion. An explicit type conversion is user defined conversion. This is your user defined conversion. The explicit type conversion is also known typecasting. The name of this is typecasting, or you can say explicit type. Typecasting in Python is performed by type, and type means your type is the function. Type is the name of the function. So you define with the perform with the type function of appropriate data type in the following manner. For example, you write down first data type and then you write down the expression. How you do it? For example, we do the practically here. For example, you write down int 6.9. We write here int 6.9. So its answer is 6. This is your explicit type. This is your explicit or type casting, you can say. But when you write down float 6.9, so it always give the answer 6.9. But when you write down float 2, so 2 is your integer number, but we define here float. So it gives the answer 2.0. This is your explicit type, or you can say type casting. So first you write down the data type. Data type is your int, float, str, and your complex. And then you write down the expression. Expression means your any value here, your 3, 4, 7 point value, string value, any value. For example, if we have a is equal to 3, a is equal to 3 and b is equal to 5.0, then b answer is always 5. If you write down int b, then it have the value is 5.0, but you give the value is 5. But you write down d float a, and a is the integer value, so it gives the answer in the floating point 3.0. Will assign the value 3.0. Okay, and here you see beta some data type conversion functions. First is your any number convertible type float, a string having digit. For example, you write down int 7.8, so it always give the answer 7. It gives the always answer 7. Floating point number to integer convert. This is called floating point number to convert into integer conversion. So floating point number convert in integer, and you write down for example int 3 4 when we write down in between the inverted comma or in a single quote, when you write down in this way, then this means this is your string. This is your string. So when you write down int 34 string raised to power 10, it will give 34 string to integer, so it convert the value string to integer. Like let us see here, you write down int, and you write down, for example, 56. uh, Write down after that bracket, and then you write down the expression, and we write down the expression here, the string expression. So it answer is only 56. Okay, and see more here. Any number convertible type a float a string having digit. So here when you write down the floats, your integer will be convert in the float, your string also convert in the float. So always give the answer in floating point. Number complex, when you write down the complex data type first, and then you write down the integer value, float value, any value, then always give the answer in complex number. So it convert the your integer, your float number into your complex number. This is very interesting beta, this fourth point. Number boolean, number boolean, str3. When you write down str3, 3 is the integer, but it convert the integer to string. It convert the integer to string. How it convert it, you see here. We write down str, and we write down, for example, 34. So it gives the answer in 34. This is your string. But when you write down str, and we write down 5, 5 is an integer value, 5 is our integer value, but it display the answer in string, so it display the answer in single quote. For example, you write down here str and 7.8, then it again give the answer in string with single quote str. When we write down the any statement or any expression in the code, that means this is your string value, this is your str value. Okay, so always convert your integer to string, floating to string, your complex to string, octal to string. So every time you convert it in like this. Next conversion is your, next type is your bool type, any type. Boolean, bool, here we use the bool data type. So when you write down, for example, again come on your screen, your Python. For example, you write down bool, and in bool we write down 5. Okay, so its answer is true. And again we write down bool, and here we write down 5.6. So again its answer is true. So always it gives the answer in true and false. Why? Because bool is a 0 and 1. So when you write down the 0, so it gives the answer false. But when you write down the bool 1, so it gives the answer true. So you write down any value between the bool, it always gives the answer true. But you write down the 0 value, then it gives the false. For example, we write down bool and 5 greater than 6. So its answer is false. But when you write down bool 5 less than 6, yes, 5 less than 6, so its answer is true. So it convert in this way. So this is your typecasting. These all are your typecasting. So here we convert the integer to bool, and always answer of the bool is true and false. Clear? So these all are your typecasting. And one more beta, typecasting issues. Some have typecasting issues, so everyone underline this. Assigning a value to a type with a greater range from short to int, short is a data type and long is also a data type, poses no problem. No problem is there. However, assigning a value of larger data type to smaller data type, no problem. You assign the value integer to float, no problem. From floating point to integer may result in losing some precision only. For example, you write down 3.7, but you write down the integer, so it always gives the answer 3. So we lose the precision of zero point 0.7 here. A floating point type to integer type conversion result in loss of the fractional part. Original value may be out of range for the target type, in which case result is undefined. Now take one example here. Which of the following expression will yield a boolean type value as its output? So beta, in boolean type, every numerical you can write down here. For example, you write down 10 greater than 2, 2 not equal to 4. So it gives answer in true and false. But when you write down 2 plus 5 comma 6 plus 6, so what is the answer here? We see Again open it, we restore it, and here we write down the statement bool, write down the function name is bool, and then you write down 2 plus 5 comma 6 comma operator is there, and here we don't define the any operator, but in boolean expression you only define the operator, so comma are not acceptable here, so it gives you the error, it gives you the error. So you see this error is displayed here, but when you write down bool 2 plus 5 plus 6 plus 6, so it gives the answer true. So expression, in expression your values are acceptable, but your comma is not any type of operator, is a operator, but it used to differentiate the two statements, so don't accept by the boolean here, and so this is the not your boolean. And next is here you see, here you see beta and not are used together, so this is also not the boolean type, it again give you the error, so it is not the boolean. Here you see we use the bracket, double bracket, and use the comma operator here, but we don't define what will we do by the plus minus multiply, so it gives you error. But when you write down 2 multiply 2, so its answer is 2 square is 4, so 4 is equal to 4, always you are 4, so this is true, no problem is there. And when you write down 4 comma 2 multiply 2, no, it's the wrong way, you don't write down in the this way, you define between these any operator here. But when you write down cat less than, this is a string, this is also string, no problem, you define in this way, you define in this way also, you define this way and this way, no problem is there, these all are your acceptable. So which of the following expression will yield in a boolean type? I value as it 1, 2, your 6, 8, 9, 10, 11. 10 is not here, but you write down here, beta 10 is also included here. Okay. Next is your write boolean expression in Python for these condition. For example, we write down x is a factor of y. So factor of y, that is the x division or evenly x into y. So you define it x mod y. So is equal to your 0. So we define the factor, so always when you divide any value and we consider the 0 value, then only we create the factor here, so you do the practically also beta. Now introduction to Python standard library. We have some standard library which have collection of so many modules and collection of functions, user defined, not user defined, the library function already defined by the Python language and defined by the some other language, like you are defined by the object oriented programming language. So built-in function, some built-in function also in your uh, Python is there. So other than built-in functions, standard library also provides some modules having functionality for specialized action. A Python module is a file which contain, a Python module is a file which contains some variable and constant. Variable are changeable, but constant are the fixed variable, some functions and objects, etc. Defined in it, which can used in other Python program. In order to use module, you need to first import the module. So when you are working with the mathematical functions, mathematical calculation, then you import first, import math. But you work with the string, then you import the other in a program, and then you can use the module function, variable, constant and other object in the program file. Let us learn to use some such module in the following line. Shall talk about how to use the random and static module Python standard library, but here we use the first working with math module of Python. And math is your library function, math is your library function. So other than the built-in function, Python make available many more functions through modules, through modules in its standard library, in its built-in functions, in library functions, you can say. Python standard library is a collection of many modules. Many modules means like your math module. Four different functionality: module, time, offer time related to the function. For example, you want to calculate the square root, then only write down maths.sqrt and then write down the expression. It automatically give you the square root of the value of the expression. Okay, so for this, first you import the math. First you do import the math. So you write down on screen, import math. After importing the math, math is a function. So after that, you do all these functions. Better you do it uh, on your system. So practical implementation of these functions is very important. So now first we are talking about the seal math.seal num. So this is the method how you write it. Math.seal num means your numeric value. The seal function return the smallest integer or not less than number. Not less than number. It don't display the answer less than the number, but it display the similar value. For example, you write down 2.03, so it gives the answer to 3. So how you implement it? Open your Python and you write down here import math. Okay, after that just write down math dot ceil, and then you write down, for example, 2.03. Then it always give the answer 3. But when you write down math dot ceil, so it gives the nearby answer to you, 2.0. So it gives the answer to 2. It give answer to 2. So what is the difference here? 2.03 give the answer to the 3 because it don't give the answer less than. But when you define here math dot seal and then you write down 2.3, then it give the answer 3. So these all are your uh, seal function. And if you want to implement the square root, then just write down math, and here you write down, for example, math.sqrt, and then you write down here, for example, 49. So it gives the answer 7. And when you write down math dot square root, we find out the square root directly. Just import the math, just import the math function, and after that you can also say math module. So after that you just write down the math dot and the function name. For example, again math dot sqrt, and here we write down 81.0, then it always gives the answer 9. So these all are the methods. So square root, same like that, your exp. And what is the exp function return the natural logarithm e raised to the arg power. So when you write down math.exp 2.0, so it gives you the value e2. Better you do the practice of these all functions in your system. Next is your fab function. Fab, fabs. Abs stands for absolute. F stand for function. FABS absolute value. When you write down the value in the points, so it always give the answer in whole number. Like you write down minus 1.0, it gives you answer only 1.0. So it display the absolute value always. And math dot floor function return the largest integer not greater than number. We already know floor function. Floor function always give the answer in float whole number. For example, you write down 7 divided by 2, so it give answer 3.5, but you write down floor function, so it give only integer, but always give the answer your integer greater than the number, not greater than the number, the largest integer number. Same like your log function return the natural logarithm for number. If you want to display the logarithm of the number, then you write down the log and then you write down num base. And for example, you write down 1024 comma 2 will the logarithm of 1024 is the base 2. So these type of function you can implement in and more log 10 And power is simple. When you write down 2 comma 2, so it display the 2 raised to power 2 is 4. So how you define the power function here? Just write down math dot pow, and then you write down first value, and then you write down your second value. So it gives the power 2 raised to power 2. But when you write down math dot pow, and you write down 2 comma 3, so it means 2 raised to power 3. But we write down 2 comma 4, it means 2 raised to power 4. But when we write down 4 comma 2, it means 4 raised to power 2. Clear? So first write down the value and then raised to power. For example, 4, so 2 to the 4, 4 to the 8, 8 to the 16, so its answer is 16.0. so it gives the in this type of outputs beta. Same type you calculate the sine. Everyone know about the sine function. Return the sine of arc. The value of arg must be in the radians. So you write down just math dot sine, and then value write down any 90 degree, 80 degree, 70 degree, anything. Same like you define the cost function, tan function, degrees, and radian. Now what is the radian? Radian is different for us. The radians convert angle x from degrees to radian. So math dot radian 779.91 would be give 3.14. So it display the radians of the degree. It display the radians of the degree. Okay. So the math module of Python also makes available two useful contents, namely pi and e, namely pi and the e. E means exponentation, and pi you everyone know 3.14 22 by 7, which you can use as math.pi. If you write down math.pi, so it gives the answer you pi is equal to 3.14, this one. And math.e, so it display the exponential value 2.718. Following our example of valid arithmetic expression, these are the valid, and below these invalid. So valid are when you write down a is equal to 3 comma b is equal to, these are the values for example. And you write down power, in power you write down a divided by b then raised to power comma 3.5, acceptable. When you write down math sine p divided by q plus cos a minus, but here you write down the comma operator, then this is the invalid. But you write down x by divided by y plus math floor, so it is also acceptable. You write down in this way also, you write down in this way also, these all are the valid arithmetic expression. But when you write down two operators together, not acceptable beta, this is the wrong arithmetic, invalid arithmetic expression to operand in continuation. Or you write down in this way, you don't define here plus minus multiply, so it don't understand what will do with the q and bracket, so operator missing between q and the a. And negative number power, non negative number power is just when base is 0, so what is the power of 0? So domain error, because if base is equal to 0, then exponent should not be greater than is equal to 0. So it not greater than is equal to 0. Math dot log minus 3 and then plus p divided by q. So domain error, because logarithm of a negative number is not possible. But here learn one more point here beta. Write the corresponding Python expression for the following mathematical expression. If you want to give a square plus b square plus c square and square root of this, so how you write in the Python language? So how we write it? So you write down a square means a multiply a, b square means b multiply b, and square means c multiply c, and square root you write down math dot sqrt. Okay, same like that you write down in 2 minus, so y multiply pi math dot, so here we use the exp function, 2 multiply y and plus 4 multiply y. So you don't understand, you define your formula what you want to calculate it. Same like that, p plus q divided by. So you write down here divide sign, math power, power is r plus s. So you write down r plus s comma 4. So it defines the r plus s square 4 power 4. So same like you define if we want to cos x divided by 10x. So first you write down the math dot cos x divided by math dot 10x and then plus simple x. And this formula you write in the this way in Python, then only they calculate the calculation. Same like you radius, and if you want to find out the area, then you write down math dot pi r square. If you want to write down the pi r square, just you write down math dot pi, it display the pi value, multiply r we have defined already here, so it define the pi r square. So same like volume, how to find out the volume, 4 multiply math pi multiply math dot power r raised to power 3, so it means r raised to power 3, and here pi, so it multiply with the pi and it multiply with the 4 here and display the answer. Okay, so these all are the method, and do the practical of these. Beta, you do all these library functions in your computer system, and you already all do the typecasting, like integer to floating, floating to integer, string to integer, integer to string, and complex to integer, integer to complex string. So you do the practice of these all. Thank you so much for watching this video. In next video we meet with the next